This is Geometry Unit 7 Pretest Solutions, number 1. So the circumference is approximately 80 meters, so that means that circumference is equal to 80, and we know that the equation for circumference is pi times diameter, and we are trying to find the radius, so we can actually change this to 2 pi times the radius, because 2 times the radius is the diameter. So what we do is we set 80 equals to 2 pi r, divide both sides by 2 pi, so I'm left with 80 over 2 pi is equal to the radius, or 40 divided by pi is equal to the radius. So 40 divided by pi, I know pi is about 3-ish, so I know if it was 2, then it would be 20, but it's less than 20. The only thing that's less than 20 is b. I don't actually have to do any math, any actual number crunching for this one. Number 2. Find the area of circle P with diameter of 18. So area, that's pi r squared. Notice that it gives us the diameter, so to get to the radius you need to do half of that. You'll get 9 centimeters. So square 9, I get 81, and then 81 times pi, there it is, 81 pi centimeters squared. What is the exact length of EF? So the equation here is I take the angle 120 degrees, and that's going to be divided by 360 degrees, and that's going to be multiplied by, since it's length, we're talking about circumference, and circumference, as we have up here, is 2 pi radius, or pi times diameter, whatever you prefer. Alright, so the radius here, it tells us that is 12 meters. 12 meters. So this is going to be 24 pi for this block right here, and then 120 divided by 360, that simplifies to the fraction of 1/3. So this, all of this divided by 3. 24 divided by 3 is 8. The correct answer is 8 pi. Number 4. So we have AB is equal to 4. So this entire distance here, this entire distance is 4. And it says that BC is twice of the AB. So this entire length is 8. And then CD is twice of this. So that is 16. All right, and we're looking for area. So area is pi r squared. And we don't have radius here. We have a diameter. So the radius here is 2. So this one is going to be 2 squared times pi. And this is only half of a circle, so it's all of this divided by 2, because it's only half of the area. All right, this area for this circle is going to be, well, the radius is 4, so it's going to be 4 squared times pi, and then divided by 2, because it's only a semicircle. And this one is going to be 8 squared pi over 2. All right, 2 squared is 4. 4 divided by 2 is 2, so we're left with 2 pi. And 4 squared is 16, divided by 2 is 8, so we have an 8 pi. And 8 squared is 64, divided by 2 is 32 pi. And then I add these up, 32 plus 8 is 40, 42 pi is the answer. Number 5, the area of a circle is 64 pi. I'm looking for circumference. Okay, well, area is 64 pi, so 64 pi, and I'm going to set that equal to the area formula. Area formula is pi r squared. Divide both sides by pi, those cancel out, and I have to take the square root of 64 to get r, and r is equal to 8. Now that I have the radius, I'm looking for circumference. Again, circumference is 2 pi radius, or pi times the diameter. So when I do that, I get 2 times 8, which is 16 pi. Circumference is 16 pi, B. Number 6. So RS is equal to RU. So this length here is equal to this length here. Oh, sorry. This arc here is equal to this arc here. Then RS, this length that it's talking about here, should be equal to this because chords have congruent arcs. So correct answer here is RU, B. What is the perimeter of OPBDQ? Okay, AB equals 6, so this entire length is 6, which means this is cut into half. This is a length of 3 for this length right here. And CD is equal to 8, so this is half of 8, so this is going to be 4 right here, because again, when you meet a chord at a right angle, it's going to cut it in half perfectly from the center. And BD equals 6, so BD is equal to 6, OP is equal to 4, and OQ is equal to 3. I just have to add all of these up. 6 plus 4 is 10, 10 plus 3 is 13, plus 4 is 17, plus 3 is 20, 20. Number 8. All right, RS and RT find Y. All right, so this angle is Y. This is basically an isosceles triangle because these are the base angles that should be equal. Those were the same length because those are tangents. So I basically need to do 180 minus 38 to find how many degrees are left to split between these two angles. and I find that that is 142, and then divide that by 2 because there are 2 angles here, and you get to 71 for your answer. And number 9, okay, this one was a little bit challenging. So if this is 70 and this is 110, then this angle, I can do this with a highlighter, this arc length right here should be 180. If this is 180 degrees, that means that if I drew a point from here to here, where there's a point of tangency, I get a diameter. It goes through the center. All right, so now that I have a diameter, I can find this angle. I know that this angle is 90 degrees because that's where it hits the point of tangency. So 90 degrees, and I know that this angle is, judging by 70, it's half of 70, so this is 35 in here. And then 35 plus 90 is 125, and I need to do 180 minus that because that's how many degrees are in a triangle. And when I do that, I get 55. Correct answer is C. Number 10, so A, B, and C, D are chords. Oh, AB is, so this should have been a B. AB is a chord, just judging by the question. AE equals 5, so this was 5. BE equals 12, so this is 12. CE equals 6. And what is the length of DE? Question mark. So you just multiply these together. 5 times 12, 5 times 12 needs to be equal to 6 times, we'll say that that question mark is an X, I guess. We'll make that an X. All right, so 5 times 12 is 60, is equal to 6x, therefore x is equal to 10. Correct answer is C. Number 11, AB. Notice that there's not arrows on the end. If it was arrows, then it would be secant, but because it's just talking about this length between A and B, just this line right here, that is a chord. And HF is this tangent line, so this should be tangent. Number 12, circumference of the circle. So circumference again is 2 pi r. The radius is 3, so multiply that by 2 and I get 6, so it's going to be 6 pi centimeters. I should note here that whenever you have an equal sign, you should have a pi in your answer. When it's at approximately equal to, like this, you should be using 3.14 as a replacement for pi. I could go out and say 3.14 times 6 and do long division, or not long division, but I can multiply these through this way, but I'm going to use a calculator because it's faster that way, but you should be doing this on your paper. So 3.14 times 6, and you get 18.84. 18.84 centimeters. Don't forget units. All right, length of arc AB. So now I'm just talking about this part right here, the 120 degrees. So that's going to be 120 divided by 360 times the circumference. Circumference was 6 pi, so times 6 pi. Again, we're equal to, so we should have a pi in our answer. 120 over 360 turns into 1/3, so it's 1/3 of 6 pi. And 1/3 of 6 is 2, so the answer is 2 pi. Don't forget your units, centimeters. Length of AB, approximately equal to. So now I need to do 2 times pi. Well, pi is 3.14, so 6.28 centimeters. Number 14, circle area. That's, again, pi r squared. And we know what the radius is. It's 5, so 5 squared is 25. 25 times pi. And don't forget your units. It should be feet squared. All right, circle area approximately equal to, again, so I would be doing 3.14 times 25 on my piece of paper, but I'm going to do that with a calculator, so 3.14 times 25, and that's 78.5, 78.5 feet squared. All right, sector area, so it's talking about this shaded region, which is 90 degrees. I guess if it was to scale, it would look like this, because that's supposed to be 90 degrees right there. But regardless, so I need to do 90 divided by 360, all that times my area of 25 pi. So 25 pi, oh yeah, 90 divided by 360, that's 1/4. So this is equal to, and I'm just going to write this here, it's 25, I can do a better 5 than that, 25 pi over 4. And that's going to be feet squared. You could have left it like that, or you could have left it as 25 divided by 4, what is that? That's 6.25, I think. Let me just double check. 25 divided by 4. Yeah, 6.25, and I need a pi in there too. Let me move all this stuff. 6.25 pi feet squared. And when I approximate that, I need to do my multiplication. I'm going to do that now. So it's 6.25 times 3.14, so 19.625. 19.625 feet squared. So on to 16, the measure of CD. So I'm looking for this length right here. That angle, how do I find that? Well, 47 plus 50, that's going to be 97. So this remaining angle right here is going to be, so that's, what did I say, 97. So 3 more will make that 100. So 83. 83 degrees, which means that this arc right here, AB, is 83 degrees. And because we know that AB and CD are the same, since this and this are the same given by the problem, we know that this arc and this arc must also be the same. This must also be 83 degrees. So 83 degrees. And measure of angle CED, CED, and then because this arc length is 83 degrees, this also must be 83 degrees. All right, for problem 18, we know that AB and DE are the same length. So AB and DE, we notice this is 6 if it's hitting this chord at a right angle. CF is hitting it at a right angle. Therefore, this length must also be 6. Since these two are the same, we know that they're equidistant from the center, so this must also be 5. And since these are the same lengths, this should be 6 and 6 here. All right, so we know that the pentagon has a perimeter of 29. So what is BE, the remaining length down here? So 5 plus 5 is 10, plus 12 is 22. So 29 minus 22 minus 22, that's 7. 7, do we have units? No units, okay. Number 19, FB, that arc, so this arc right here, how do I find that? Well, I know that this is 120 up here, this is 40 down here, so that adds up to 160. So I need to do 360 minus 160, 160, and that will tell me how much remaining angle is between this length and this length. So that's going to be 200. So that means since these are equal, this must be 100 over here. This entire length over here must be 100. And since I'm only finding half of it, since this line CF bisects this arc length, half of that is 50 degrees. All right, so measure of angle A. So the quick way is just doing 180 minus whatever this angle is to get 30 degrees. But maybe you don't know how to do that, so maybe you have to go through this process of making this 90, this 90. This is 150, which means this angle here is also 150. So think about this as a quadrilateral. This quadrilateral has 360 degrees, so 90 plus 90 plus 150 plus this unknown angle x plus x must be 360, and from there you'll get x is equal to 30 the same way. But the shortcut again is just doing 180 minus whatever this is. All right, number 21, what is the perimeter of quadrilateral ABCD? All right, so this must be 3 as well. Both of them are radii, and 8 are the same. This is just a property of tangents where this and this must be the same if they're tangents. And so 8 plus 8, oh wait, there's a fast way. 3 plus 8 is 11, and then double that to get 22. 22, and our units here are inches. All right, the measure of angle EFD. So we're looking for this angle measure right here. So obviously if we could find this arc right here, we could take half of that to find angle F. That might work. What else do we know? Well, let's just start filling things in. So we know that if this is 60, half of that must be 30 in here. Does that help us at all? It might. Ooh, okay, this is what helps us right here. Look at this. This is a diameter right here. Since that is a diameter, this must be a right angle. Because this is an inscribed angle and it should be half of this entire arc length over here. This entire arc length is 180 because this is a diameter. 180 divided by 2 is 90, therefore this angle F in total should be 90. So 90 minus 35, and that is 50, wait, it is, yeah, 55. 55 degrees. All right, measure of angle FDA. So FDA, oh, we already found that by accident. Yeah, that's already 30 degrees. And on to the last two problems. So we have a quadrilateral inscribed in a circle. We're looking for x, this length here. So this is just going to be our equation where we multiply our chords. So it's going to be 10 times x is equal to 5 times 6, which is 30. Divide both sides by 10, x is equal to 3. So 3, so don't forget units, centimeters. All right, measure of angle ACB. ACB, so we're looking for this angle right here. That's going to be a little bit tricky, but this is an inscribed angle for 30 degrees, which means this arc DC is 60 degrees. It's double that. This interior angle is 45, which means AD is double that, 90 degrees. And this angle here, 65, so double that, and I get 130 degrees for BC. You'll notice that we have one missing arc length up here, so I just do all of these, add them up, subtract 360, subtract this from 360, so 90 plus 60, that's 150 plus 130 is 280. So 280 and 360 subtract 280, that's going to be 80. So we know that this arc length up here is 80, and this inscribed angle that we're looking for is half of that, so it should be 40 degrees.